Today we are working on proportions. This is section 3.9 of the Green Book, page 150, 1 through 37 odd. We are solving proportions, using proportions to solve problems. All right, so proportion is a statement of equality between two ratios. So if I have A over B, that would be considered a ratio of two numbers is equal to C over D. What we can do is we can multiply what's called the means and the extremes. AD would be the extremes, BC is the means. I don't use that language very much, but that's what they're officially called. So, a lot of times the kids call this, oh, you do it like a butterfly. We call them cross products. So let's take an example doing this with numbers. I know that there's an easy way to do this particular problem. In this particular problem, I'm like, oh, well, 5 times 4 equals 20, so 3 times 4 would be 12, right? But that only works with friendly numbers. So we're going to do our proportion method and solve it by using our extremes and our means. Yes, question? Okay, so what am I going to do?
You're going to multiply 5 times x.
5 times x, bring it down, equals what?
Equals 20 times 3, which is 60.
And bring that down, which is 60. You can write that down like that. Sometimes I write it, hold on. If you can do 20 times 3, or you can just multiply it out. Doesn't matter.
Then you divide by 5.
Divide by 5, and x is equal to 12. Okay, I'd like you to pause this and try the next one, number 2, using the extremes and means method, or the cross products. Okay? What? Okay, let's check our work. So we are going to be, let me get caught up here. We're multiplying 5 times x, and 7 times 30 is 210. And then we divide both sides by 5, and we get x equals 42. Now, the reason why we learn it this way, because let's say I'm given something like this. 4 over 7 equals x over 30. If I'm doing 4 over 7 equals x over 30, there's no number I can multiply by 7 to get 30. Do you understand? So we'd have to use our cross products. So that's where we're going. 7x equals 120. Divide both sides by 7, and x equals 120 over 7. Now, we can leave it as a reduced improper. Is everybody understanding why we're using cross products? The examples they give are not really great examples to really... Most kids want to do what's easiest. If I'm on a test and nobody says use, I probably would do it the easier way too. All right, let's throw a variable in there. What am I going to do? Okay, Nicole, what do you think we would do?
You would have to bring it down.
Okay, and so what's this going to be?
2x multiplied by 30.
Equals?
15.
Good. Now you can multiply that right away, and 2 times 30 is what? 60x equals 15. I would be okay if you skip this step, but it depends on how you want to do it. And now what am I doing to get the x alone?
You would divide by 60.
Yep, divide by 60. Earlier today somebody said divide by 15. 15 doesn't help us to divide by 50. We want to divide by what's closest to the x. And x, and then we just really have to reduce it. 15 goes into 15 once and into 60 4 times, so it's 1 over 4. If you had done 5 and it goes in 3 over 12, you would still have to reduce that. Reduced fraction. Yes?
When
I don't care about the arrows. Okay, what am I doing with the next one? What's it going to look like? Elise?
So you'd multiply 3 times 2x plus 1 with like the distributive property.
So 3 times the quantity,
Quantity of
2x plus 1, right, equals?
equals 20.
Good. And then we distribute.
6x plus
6x plus 3 equals 20.
subtract 3.
Subtract 3. 6x equals 17. Divide by 6, divide by 6. And x equals 17 over 6. Okay, questions? You guys okay with a variable here and there? Okay. So, all right, so we can set our proportions up. I'm going to go a little bit into this, not as much deep as my PowerPoint is. So you can notice that we're comparing two things, the height of a tree and the shadow of a tree. And we've got the height of a man and the shadow of a man. So I could set my proportion up like this. And in this case, how we're really setting it up, the x really represents the height. The top one, the numerators all the way across represent height, and all the way across it represents shadow. And notice the first one, I'm really talking about, this is the big, or we should say to the tree, and this is to the man. Sometimes I call it big and small. So that's one way to do it. Another way would be looking like this. Now notice I've got over here all the way across, this is the tree and this is the man, and x and 6 represent the height, right? And this represents the shadow. You guys with me? Okay. So as long as the way you're setting it up, that across it represents the same quantity, right? Okay. One example of something that would be wrong. Notice here, this is a bad proportion setup. So x and 6 represent the height. So this would be the this is the height right here, but the 5 is the shadow. And they're not the same one. Do you understand? So this is the height, and this is the shadow of the man. And this is the height of the man. Does that make sense? I mean, height of the tree. So it's not set up correctly. What helps us is if we use words. So generally we're going to get, okay, we can do this. I don't really do this for the kids, but green is to grass is what is to sky. Blue is to sky. Sacramento is to California, the capital of California, as DC is what? United States, right? This is a tricky one. Hand is to glove, like it's not foot. A hand goes into a glove. A shoe goes into a shoebox, yes.
Yeah.
It would be the other way around if, I know, oh, that would work, a shoebox. It would be foot if shoe was in the bottom, right? Shoebox, but a closet, a sock would be okay too. All right, so let's talk about word problems. The best thing, first of all, your biggest clue that you set it up like a proportion is when they give you 3 quantities and ask for a fourth. Here's quantity number 1, quantity number 2, quantity number 3, and they're asking how many for 4. So what am I comparing? In words first. First of all, what's our unknown? What is X gonna stand for? Cookies. Okay? So in words, what am I comparing? Yep.
You're comparing 6 cups of
I don't want numbers, in words.
You're comparing the amount of flour to make
Okay, cups to
cups to cookies.
cups to cookies. Now, I don't care if you set this up cookies to cups. Or you could use flour instead of cups, right? And so now we are going to make a proportion, and whatever is in the numerator is always going to represent cups. Whatever's in the denominators are always going to represent cookies. So the first ratio we add, Chloe, would be?
It would be the cups. It would be the
6 over 54. And then where do I put the 10?
on the top.
In the numerator, and the what goes in the denominator?
Yes.
The X. And so now we are multiplying, doing our cross products. I get 540 equals 6X. Okay, I just want you to see, if I had set it up here, cookies to cup, it would be 54 to 6 equals X to 10. I'm still getting 540 equals 6X. Do you see how these are the same? It doesn't matter what you do as long as you keep it straight in the numerator all the way across and then the denominator. I really like it when you set it up with words to keep it straight in your head. And then we're dividing by 6, X equals 90, and 90 represents 90 cookies. 90 cookies for 10 cups. Again, with a proportion word problem, they set you up with 1, 2, 3 quantities, and they make you look for the fourth. That's your tell-all to set it up like a proportion. Yes, I understand. No, I don't. Okay, question. What? It doesn't matter as long as in the end, in the end, I do want to see 90 cookies. Right at the bottom, the beginning one, I guess you don't necessarily have to in a problem like these. As we get more into word problems, you should identify your unknown. It won't hurt you to identify your unknown. So now I've got one more problem, and I want, whoa. Let's identify our unknown. What is our unknown here? Widgets. X stands for widgets. Okay, you guys pause the recording and try this next problem. All right, so how am I setting it up in words? Words first. Jamie?
Words.
Yeah, what 2 words do you want me to set up? What's the proportion?
Widgets and hours.
Widgets to hours. Okay, and what do I get?
91 over 7 equals X over 12.
Good. Okay, and then what would I do?
You multiply 7 and X, you get 7X.
And I'm going to show you something. 12 and 91. I'm not going to multiply it out because I'm thinking that 7 divides into 91, and it does. 7 divided by 7. So I can simplify it before I multiply. So 7 goes into 7 once and into this 13 times. So then I'm just multiplying. Since I knew that, 12 times 13 is what? 156. And that stands for 156 what?
Widgets.
Widgets.
Thingamabobbers.
widgets in 12 hours. All right, and that's it. We're out.
Technically, they would be a widget.